All right, let's just jump right in. What if you could give an AI assistant like Claude direct access to the files on your actual computer? I mean, not just uploading things, but letting it read your documents, create new ones, and even organize your folders for you. Well, this isn't some far-off future idea. It's a real feature you can turn on right now using something called a local MCP server. Today, we're going to walk through exactly how to do that, and then talk about the huge, critical reasons why you might want to seriously think twice. And I'm not making this up. This quote is pulled straight from the official documentation. The promise here is absolutely incredible, right? The idea of turning Claude into a true local assistant that can help manage your digital life right there on your own machine. But as we're about to see, with that kind of power comes some very significant risk. So, here's our game plan. We'll kick things off by explaining what these local servers even are. Then, we'll get practical and do a step-by-step guide to connect one yourself. And after that, we're going to hit pause for a critical security warning that you really can't afford to skip. From there, we'll put all this into the bigger picture of AI tools before we wrap it all up, weighing the power against the peril. Okay, so first things first. To give Claude this kind of access to your computer, you need to set up what's called a local MCP server. So what on earth does that actually mean? You can think of it like a bridge. Claude exists out there in the cloud, but all your files are right here on your computer. And MCP, which stands for Model Context Protocol Server, is just a little program you run on your machine that acts as a secure translator or a controlled bridge between those two worlds. It's what lets Claude use tools that can actually do things on your computer. And the capabilities are pretty amazing. Once you've got this file system server running, Claude can read files, whip up new ones, tidy up your desktop, and even search through your documents for you. But that last bullet point is the really important one, at least in theory. Every single action it takes is supposed to require your explicit approval, so Claude can't just go rogue. You're the gatekeeper for every single move it wants to make. Okay, let's get into the how-to. If you're feeling adventurous and want to try this out for yourself, here is the step-by-step process for getting this file system server up and running with the Claude desktop app. Before we get started, you're going to need two things. First, the official Claude desktop application, for Mac or Windows. And second, you'll need something called Node.js. It's a super common tool for running these kinds of programs. The documentation suggests grabbing the LTS version, that's long-term support, just for stability's sake. Now, this is the most important step. It might look a little technical, but it's really just a block of code you copy and paste into a configuration file. Think of it like an instruction manual. It tells the Claude app, hey, I want you to start the file system server. And crucially, it also specifies exactly which folders on your computer it's allowed to touch. This is where you limit its access to, say, just your desktop and documents folders. The whole process is actually pretty simple. First, you open up the settings for the Claude desktop app itself. Then you'll find a developer tab and a button that says Edit Config. That's going to open up that special JSON file. You just paste in the configuration we just looked at, save the file, and then completely quit and restart the app. That's it. If you did it right, you should see a new little server icon pop up in your chat window. Okay, so we've built the bridge. Claude can now talk to our files. It seems powerful, it seems useful, and it even has that nifty approval system. But this is where our story takes a very, very sharp turn. A security research firm took a much closer look at how this whole thing is built, and, well, what they found is pretty alarming. This is the exact question that security firm LayerX asked, and their answer was a loud, clear, resounding no. In fact, they gave the vulnerability they found a CVSS score of 10 out of 10. For anyone who doesn't know, that is the highest, most critical security risk score that exists. It literally does not get any more severe than that. We're talking maximum danger level. Just let that sink in for a second. A zero-click attack. What that means is a hacker could potentially take over your entire computer without you doing anything wrong. You don't have to click a bad link, you don't have to download a weird file, nothing. The attack could be triggered by something as innocent as a calendar event showing up on your schedule. So what exactly is this remote code execution, or RCE, they're talking about? Well, it's pretty much a hacker's dream come true. It means an attacker, sitting anywhere in the world, can run their programs on your computer. They can steal your files, install malware. Anything you could do yourself, they can do too. It is a total, complete system compromise. And this right here explains the core of the problem. You know how browser extensions in Chrome are sandboxed? It means they run in a little protected bubble, a padded room with very limited permissions. Well, these Claude desktop extensions are the opposite. They're unsandboxed. They run with all the same power and permissions that you have, with the keys to the entire house. So how does an attack like this actually play out? It's a dangerously clever chain reaction. So imagine you ask Claude a simple, harmless question, like, hey, check my calendar and take care of it. But a hacker has already sent you a sneaky calendar invite with malicious code hidden in the event description. Claude uses its Safe Calendar tool, reads the event, and finds that hidden code. And then, this is the fatal flaw, it passes that malicious code over to the dangerous File System tool. And since that tool has full access to your computer, it just runs the hacker's commands.
And here's the kicker. According to the Layer X researchers, when they published their findings, this vulnerability had not been fixed. The fundamental architectural issue, this broken trust between a safe tool and a high-risk one, is still there. So let's zoom out for a minute. It's important to remember that this local server feature is just one of the ways the developers are trying to make Claude more powerful. We need to see where it fits into the whole ecosystem. By far, the most common way to give Claude new abilities is through its API. Developers also build plugins and add-ons for things like Google Sheets or Slack. And then you have these super powerful, but as we've seen, super risky local MCP servers. There's also this emerging computer use feature where Claude can literally watch your screen. So you can see these local servers are a very specific, very high-privileged slice of a much bigger pie. So where does that leave us? Let's bring it all together. We've got this incredible power on one side and this terrifying peril on the other. How are we supposed to think about this? I mean, you look at the pros column, and it's tempting. Direct file access, powerful automation, that sounds amazing. But then you look at the cons, and wow, it's unsandboxed, running with full privileges, there's a critical, unpatched vulnerability, and it fundamentally breaks the trust between safe and dangerous tools. The risk side of the scale is incredibly heavy. The final recommendation from the security researchers who found this flaw is as stark and clear as it gets. They say that until meaningful safeguards are introduced, you just shouldn't use these MCP connectors on any computer where security matters at all. And really, this all leaves us with a massive question for the future. As we keep racing to make AI more powerful, more capable, and more integrated into our lives, giving it access to everything from our calendars to the files on our hard drives, we have to stop and ask, who is ultimately responsible for keeping us safe? Is it the companies building the AI, the developers making the tools, or is it us, the people actually using it? It's a question we are all going to be grappling with as this technology keeps pushing